So again, we're explaining, or we're trying to prove that this expression is equivalent to this expression. This is, the and is not a logical and. It's just literally saying compare those two. If you just do De Morgan's laws, you will come to this expression, which is equivalent. However, we can also do a truth table to prove it. So P and Q is true, false, false, false. Not P and Q is false, true, true, true. If we do not P or not Q, so this is false. Not P is false, not Q is true, so that's true, true, true. These are in fact equivalent. So I didn't record how to work through problems 1 and 2, but I'll record the remainder of this review. I'm not about to erase that. All right. Do I need to go over any of these other ones? What you have to do? Again, once you make a truth table, it makes each of these fairly easy. Just make your truth table and explain. Cool.
I'm just reading over number 4's problems. So do we need a truth table for that one?
You can create one. It makes it a little bit easier. It says, consider the operator, again, I'm just going to call this hashtag. Defined so that A hashtag B is true if and only if A is false and B is true. So, and again, let's not tie this operator to the variables A and B. It's more so the position of A and B. So if the first variable is false and the second variable is true, then the outcome is going to be true. All right, so let's not tie it directly to A and B, because if I have B hashtag A, B would need to be false, A would need to be true for the outcome to be true, right? If I have P hashtag Q, P would need to be false, Q would need to be true for the outcome to be true.
So again, just A is the first one, or just whichever one is first. It doesn't matter.
Correct. It needs to be false. All right. So let's work through A. And let's do the truth table for it. So P, Q, P hashtag Q. So this one is false, false, true, false. Again, this is only true if the first variable is false and the second variable is true, which only occurs right here. All right, so what do we need to do? We need to create an expression using the hashtag, or using P, Q, negation, and hashtag that is equivalent to that expression. And then you're going to do that one and then that one as well. All right. So how do we do this? Again, using a truth table, it makes it pretty easy. So first, let's do the truth table for P and Q. So P and Q. So this is true, false, false, false. Okay. So our first thing is we want to get this operator, using this operator in negation to match that column, that truth table for P and Q. So if you remember, this is only true if the first variable is false, the second variable is true. And so we want our column to match this. So on this row, our first variable needs to be false, and our second
Sir, are you
variable needs to
talking?
be true.
Because I'm not hearing you.
Is nobody else hearing me?
I can hear you.
I
Hear
can't.
I can hear.
You can or can't?
And
Can, yes.
yes.
Yeah.
For you, Mark, I'm going to record this and hopefully my voice will be on the recording. Well, I am recording this, so. So again, in order for our hashtag to be true, we need our first variable to be false. How would we make P false? Here,
Not P.
P.
not P, correct. Not P. So that would give us false, false, true, true. And then we have Q, so not P, hashtag Q would give us a true. That would give us true. Not P and Q, that would give us false. Not P and Q, false. Not P is true. Q is false, so our hashtag is still false. Now we compare. Did we get this expression, this truth table, using a negation and a hashtag? Are they the same?
Yes.
Yeah. So we've done problem A. Do
I did
these-
mine a little different, but I think it's the equivalent. So I did the not sign parenthesis P hashtag not Q parenthesis.
Well, is that the same? Because you would need to do. What you're saying is you did. So I have my not here. You did not P hashtag Q, correct?
Hashtag not Q.
So you did, say that again. What did you do?
I did not, it's a not sign in front of I'm sorry, in front of Q.
In front of Q?
Mm-hmm.
So like this?
Yeah.
Okay. So let's see. Obviously, we do what's inside the parentheses first. And so to make it easier, I'm just going to do a not Q. False, true, false, true. So P hashtag not Q. So we need to compare these two columns. P is true, not Q is false. So that's going to be a false. I'm just going to write this over here. False. P is true, not Q is true. That's going to be false. P is false, not Q is false. That's false. P is true, false, not Q is true. So we finally have our true. If we negate that, because that's what this negation is going to do, we get true, 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 false, which is not equivalent.
Okay, I see where okay, thank you.
Mhm.
So my question is, since we got that for A, which is equivalent to the P and Q, then we use the hashtag and everything. So are we supposed to do the table for that A or just write the statement
Which one are you talking about?
for number 3A?
3A.
Yeah. When you say
Up here?
P and Q, right there,
Uh-huh.
the
You're
P and
talking,
Q.
you're talking
wanna-
right here.
No, no, no. I mean 4A, sorry. We're in
Oh.
4. Yes, sorry, my bad, apologies.
Right here?
4, yes. You want us to do the table or just write the statement since you already did the table in general?
Well, I need, for all of these, I would like you to do your table. I've just done it for you, so it should make it easy.
So we do the same thing for B and
Correct.
C.
Correct. And show that they are equivalent or they may not be equivalent. Well, actually, I'm sorry. You need to make it equivalent. For this problem, yes, they need to be equivalent, what you decide to make. For me, logically, in my head, how I frame this is, I look at what I'm trying to accomplish, which is this row right here, this column right here. If we know the hashtag symbol typically only has one true value in it, so in this case, it's here. In this case, over here, it's up here. This case, it was down here. Wherever that truth value is for our final expression, I want that to be where it is for the hashtag. So our final expression has the true up here. So when I do the hashtag, I want the truth value up here again. So I look back all the way over. How do I get that truth value? Well, this expression needs to be false. This expression needs to be true. If I already have the true here, how do I turn this one to false? Well, I negate it. And that gets me my final expression. Let's say I'm trying to look at this row. This row needs to be true right here. I look all the way over. I already have a false here. This needs to be true. How do I do that? I would negate it. So that's how I think about doing this. You all might think differently. If, for example, in one of the problems, I need to get 3 trues and 1 false. Okay. I can kind of do how Loria said. I would have my expression, which gets me 3 falses and 1 true. How do I convert that to 3 trues and 1 false? Well, I just negate it. That gets me 3 trues and 1 false. All right, so understand where you're trying to get that one expression, either a false or a true, and how you need to negate it in order to get there. All right. Let's continue to problem 5, and that's it for homework 1A. So write each of the following in both conjunctive and normal form and disjunctive normal form. Again, conjunctive is an expression of ands, of ors. Disjunctive is an expression of ors, of ands. So in the format, conjunctive would be A or B, and B or C, and B or A, something of that nature. Disjunctive would be A and B, or B and C, or B and A. All right. Oops, went off the screen. Anyway. So that's how we need to get these expressions into using our axiomatic rules. All the rules that we've learned, how do we get there? So let's look at the first problem.
You look at the 6, third problem.
Say what?
Third problem for that one. It looks like a lot of alphabet.
Wait, this one right here?
I mean, C, problem 5C. Can we
Oh,
do
yeah.
that? Please,
Yeah, it
thank
is a lot of alphabet. You want me to do that?
Yes, instead of A or B, do C.
Nah, let's go with the shortest one.
Good try, Rita.
Now I'm gonna go with A. And I'll let you all handle the rest of those. It's funny. This looks like the longest alphabet, but it has no implications and no if and only ifs. So it's actually one of the more simple ones. So let's say not A or not B. Implies not A and C and B and not C. So our first thing, let's get this into conjunctive normal form, which is the ands of ors. So first thing, we have to distribute our not here. Actually, we don't have to. We can break this down as we see fit. So let's do our implication first. So let's handle that first. An implication again is not the first expression or the second expression. So not A or not B or not A and C and B and not C. Okay. Then I want to distribute these negations. And I'll circle what I'm doing. So first I did the implication. Now I'm going to do the distribution of the negations. So A and B or not A and C or not B and not C. It's funny. We were trying to do conjunctive normal form, and we simply just did disjunctive normal form because this is ors of ands. So we just did the disjunctive normal form. But we do need to get this into conjunctive normal form. Right. Now, at this point, because of, what is it called? Commutative, we can get rid of these parentheses. And so we just have the expression A and B or not A and C or not B and not C. All right. Let's distribute let's distribute this negation. So we have A and B, or not A and not C, or, I'm sorry, this is an or not B or not C. All right. Now,
Oh. Because the and you switch the and to or.
right, because I distributed the negation.
Which is the not. So that
Correct.
changes the and to or.
Correct. And if we distribute this over, it cancels out, so it's just C over here. All right. Now, where do we go from here? Is the question. Let's see.
Now you just have to change the or to an and.
Mm-hmm.
So would we be distributing, Dr. Brown?
Right. What do we want to distribute?
That's the problem. I don't. Is it the A and B?
That's what I'm thinking. But how do we want to distribute that? Because, let's see. I could distribute this over here. Not A or not C. And if I distribute that over, I get not A or A. I get A or not A or not C. And B or not A or not C. Or not B or C. We know that A or not A is always true. True or not C is always true. Is that correct? It's awfully quiet.
You said A or not A is always true, and not A and not C is true.
So I said A or not A, this expression right here,
Hmm.
is always true. Is that correct? So we have A, we have not A. True, true, false, 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 true, true. If we OR those two together, that's true, that's true, that's true, and that's true.
Yeah, that's always true.
And if we do a true or anything, it's always true.
Yeah.
And so it cancels these A's out and it cancels this C out. So now we are left with B or not A or not C or not B or C. And again, because this is commutative, these are all ors, we can get rid of our parentheses, B or not A or not C, or not B or C. Interesting enough, our B's cancel each other out. Our C's cancel each other out. We're just left with not A.
So is that conjunctive?
I'm gonna go with that. If you can show your work, I'm gonna accept that answer. Cause I don't know if that's officially conjunctive, but that's the most simple form of the equation.
So when you did this or not A or not C, does it matter the way we write it? Because I wrote mine like A or not B and not C.
The order in which you write it doesn't matter, because it's the same expression.
Or trying to cancel out the true statement, that might make it more difficult.
Yeah.
Yeah.
For disjunctive and conjunctive normal form, each expression can have multiple forms. So if you can show your work of how you came to it, I'll accept it. Because there is no, one conjunctive form. Maybe some expressions, if they're small enough, there is one form. However, for longer expressions, there can be multiple forms. There can be a more efficient form. So not A is a very efficient conjunctive and disjunctive normal form.
Okay.
However, if we have two expressions that we're trying to prove are equivalent, and they're both fairly long, getting them into disjunctive or conjunctive normal forms might be simpler than trying to break them down into one single expression. So as long as you all can show your work and your work is logically sound, I'll accept it. And so this class, more so than even programming, really feeds into the science aspect of computer science. For those of you who are in computer information systems, you get half computer science, half business. And this is really the science part, because there are very challenging mathematical problems and computational problems, which requires this level of thinking and this level of logical deduction. And so, like I said, this really gets into the science aspect of computer science that many people don't talk about or even think about. All right, let's talk about homework 1B. Any questions about 1A?
I have a question.
Hmm?
What about the rest? Like the homework 1A is just like 5 problem.
That's the only ones that are listed.
Because I see something like appendix, something like that. I don't know.
Right.
Yes, we have to do this one. Oh,
Well, those, I mean, these are just useful LaTeX commands that you can use to create. Those of you who are asking, how do I make those symbols? In LaTeX, that's how you would make those symbols.
Okay.
And then I think here's a truth table format that you can follow. And how you would do that in LaTeX is shown right here. So for those of you who are looking to do it in LaTeX, it shows you some commands on how to do that.
Okay.
So can we use those same command in Java?
What do you mean?
Like same command, put it in Java and you bring out the truth table?
These commands, no, these are not the same commands as Java.
Is it possible to like, for you to send us those, go up this right there, the formulas,
Where?
screw to the last, like the last one after problem 5. This,
This?
yes, because some of our computers, the symbols, not everything is in there. We're like, I'm getting some of the wrong symbols. I try to copy some of this symbol over here and it's not letting me copy. If you can like give us an access to this symbols, that would be great.
So like the
Just-
document itself? Is that what you're asking?
Yeah, just the symbol itself. So we can like have it in the Google Docs or something. So we can easily copy it and put it in an equation while we're writing.
I can try, but I can't make any promises.
Okay.
There's a site, if you Google it, that has all of them. So you can copy it. I'll find it for you, Rita, and I'll text it to you.
Thank you.
All right. So let's talk about 1B. There's only 3 problems. All right, the first one is express the negation of the following predicate formulas P. So this one is pretty straightforward. All right. So P equals, I'm gonna say, there exists a Y in a set of integers such that E of Y is false or O of Y is false. All right. Your goal is to negate this expression. So when we negate this, we distribute our negation across the expression. Remember, we have to flip the symbol as well. So when we distribute it here, remember the negation of there exists is for all Y in the set R such that it's a double negation here, so that cancels out. E of Y is true. It flips this symbol and O of Y is true. And there's your final answer.
And this the first one, right?
That's correct.
All right, so when you negate it, the E, that backwards E turns into that upside down A. I'm gonna get the whatever it's called for reference. That's what happens to it when you negate it.
The what?
That the backwards E, it turns into that upside down A.
What are those called?
That's
Oh,
something.
I don't understand what a backwards E and an upside down A is.
there is this N for all, right?
There we go. There we go.
There you go. The existential quantifier turns into the universal quantifier.
Exactly.
Thank you.
See, you already knew the answer. You didn't even need me.
All right, cool.
All right, that's problem 1. Problem 2, write these 2 in predicate formulas. So we already know there exists. Brendan, what does that symbol look like?
Upside down A.
That is not correct. There exists is what? Existential quantifier.
The
Where's
upside
that
down.
look like?
I'm looking in my notes.
Upside down E.
Yeah,
don't think
that's
we
the
learned that
E,
one.
right? That You know what I mean? The E to the left.
Yes. There exists, right? There exists. So we know there's going to be a there exists symbol. There's going to be a variable Q and a variable X. Q is an integer. X is a real number. We have there exists and we have for every. What symbol do you think is going to be for every?
For all.
Correct.
You said it's what? For every,
For every, what symbol do you think we should use for every real number?
For all upside down A.
yeah, I
Right.
was, yeah,
For
okay.
all, right. Our equation is x, q plus x equals x. So we can say f of x equals that. So we say f of x equals q plus x. And now we write our full proposition. There exists a q. And we'll say this symbol represents ints. This symbol represents real numbers. There exists a q in the set of integers for all x in a set of real numbers such that f of x is true.
Why does math gotta be so difficult with shortening things? Like who puts that Z in there and a backwards E and an upside down A? Like, come on, man.
I didn't make the symbols, I'm just using them.
Hello?
I'm just waiting to let it
Oh.
sink in. All right. Problem 3. For the following pairs of formulas, f and g, is there a way to fill in the blanks of g with quantifiers so that g is equivalent to f, g implies f, and f implies g? For each of these, your answer should either give the quantifiers that satisfy the equivalence implication and a short explanation for it, or state that this is impossible. For part A, your answers must pick at least one quantifier differently for the variables in G than in F. For part B, there is no restriction on which quantifiers you may use. So for part A, you cannot use that. All right, you have to use something else,
What? Why?
or at least one of the quantifiers. In part B, you can use the same. Doesn't matter. Now remember, in predicate formulas, order matters. So X is first here, Y is second. Down here, Y is second, and Y is first and X is second. So order does matter. How you read it, it matters. So this says for all X, there exists a Y. Right? Down here, it says there exists an X for all Ys. Does matter. So for the first one, Is it possible to make these equivalent without using the same variables? No,
No,
right, it's not possible. Okay.
You
So
said it's
not
not
possible.
possible to have it the same if we switched it around, so there's nothing we can do to make it equivalent at all.
If we want to use, we have to use a different quantifier, so we can't do this. So it had to be something of this, which is not the same. It had to be this, which is not the same, so it's not possible to make them equivalent. Now, can we make G implies F? Remember, this is not G or F.
yes.
There is a way. If we do Pat. And then can we do F implies G? Yes, again, if we do that.
So question,
Mhm.
for the F, where you say for all and there is this Y, P equals X and Y. So after the parentheses, we can just write, it is not possible to make G equivalent because they wanted us to use different symbols.
Exactly.
Then for G, we just put the symbols, like we put there's this N for all, Y, P, S, and Y.
Mhm.
Okay.
Now, I'm not gonna grade this for you four that are on this call right now. You'll get this. I'm not gonna grade this as tough as it normally would be, so there is gonna be some leeway as long as you try to show your work and you show that you put effort into it. I'm gonna give credit for effort. So don't stress about getting the perfect answer, although you want to get the best answer possible. As long as you show your effort and your work, I will give credit for that. And then you four also have shown effort by simply showing up to this study session, so it's a little bit extra for that.
All right, so just a quick question. So for A, like they're two separate problems, correct? So we're doing a separate one for F and a separate one for G. Like G is equivalent to F. G, all right,
So
yeah.
yeah, I want you to fill in those blanks to show, or at least try to make G equivalent to F. G implies F, and F implies G. So really, you have 6 problems to do.
Got you. That was what I was tripping over. Thank you.
Yeah, 3 for part A, 3 for part B.
All right, and for G, like, okay, I'm still trying to get like how we got that. Like, because F, like, all right, so there's nothing, like I said, for F, there's nothing that'll make it, we can't switch it around. Like, I'm trying to grasp why for all of it. Because it's still
Why?
kind of like not making sense to me.
Grasp Y for what?
Like, all right, so like, why isn't there anything to make like F equivalent? Like, I'm not trying, or I'm trying to see like, All right, hold on.
So for the first one,
Mm-hmm.
since X and Y are in the same positions,
Mm-hmm.
to make these equivalent, we would need to put the same exact symbols here. However, it says for part A, your answers must pick at least one quantifier differently for the variables in G than in F. So we can't pick the same exact quantifiers. Therefore, it is impossible for us to make these two equivalent. However, down here, because the orders are swapped, there may be a way to make them equivalent.
And the quantifiers are like negation, or I mean the A and the E, correct?
I'm sorry, I don't know.
Or the unifiers. You come on, man. Like it's already frustrating enough. So, yeah, the for every, and then I forgot what the other one is. There exists
For all. And
for
there
all,
exists.
and there exists.
Correct.
Right, that's yeah, I'm still having trouble with it, man. Like I don't understand. Like, yeah, like I'm not understanding how we're getting this. Like for the second part, for all right, so G implies F. Like, yeah, I'm not understanding why it makes sense for it to be equivalent.
So we're trying to do G implies F. This is not G or F, right?
Mm,
So essentially, what is the not of F? So that we can get G. All right. That's the thing we're trying to accomplish for that. What is the not of F so that it implies or G implies it? Because F is set, right? So how do we get G to imply F? Essentially, we got to do the not of F to do this.
okay.
So what is the not of F in this scenario? Well, we have orders. You not only flip the symbol, you swap the order as well. Leave. You know what? Pump this. Forget problem 3. Problem 3 would be extra credit. It's just making me frustrated. So
Okay,
problem
and
3 will be extra credit. If you get to it, fantastic. If not, I won't take off for it. Any other questions?
sure.
All right, well, make sure you get it done by tonight. Hopefully the review helped you a little bit in trying to solve these. And I'll be available by email. At least I'll try to be for the remainder of today. So just let me know. I got a couple of meetings throughout the day. So I'll try to get back to you as soon as possible.
Okey-dokey.
All right.
All right, thank you
Yes,
so
sir.
much,
Thank you.
Dr. Brown.
Thank Thank you.
Yes, sir. And I'll upload, yes, to everybody, and I'll upload this recording